Okay, this video is going to show you how to do test version number 1. Hopefully this will help you out a little bit. So here we go. Design 1 has 3 white squares. Design 2, if I count them, goes up to 7. If I count white boxes here, goes up to 11. So I could see that if I go up from 3 to 7 and to 11, that increase is going up by 4. What I'm looking for are all the answers that have 4 in the right place and try to find that bad one that does not have 4 in the right place. So here we go. All the good ones that have that 4, that plus number, I got a 4 right here for recursive. That's beautiful. I have a 4 right here in front of that X. That's beautiful. And then right here, I have another blue 4 in front of X. If I come over here to this choice, this is the only one that doesn't have a 4 right there. It has a 3 right there. And because that has a 3, that 3X means that's the one that does not match this pattern. That doesn't show it. This pattern is going up by 4, not up by 3. If I then want to find out how many after 36 steps, I'm going to plug that number in right here into X. And to see where that equation came from, if you really want, if I went back to design 0, I'm doing the opposite of adding 4. I'm taking away 4 from this 3. And if I do 3 take away 4, that gives me that -1. That's where that number in the equation is coming from, 4x minus 1. If I want to find out what 36 is, here's how I show it. F of 36 equals that 4, and where that x is, that's where I put that 36, close that parenthesis, and then I have minus 1 right there. So I need to use my calculator. Running to grab my calculator. So 4 times 36 gives me 144. And then I take away that 1, which tells me at 36 steps, or when x is 36, the y number is 143. That's how many white squares I would have if I went up to design number 36. That's how many I would have. All right, that would be 143 squares. All right, moving on. Here we go. Looking at this. If you can't tell what's going on, take these two numbers, divide them, and you'll see that number that I'm dividing out, because these numbers are clearly getting smaller by big chunks, so it's not arithmetic. If I divide 192 by 48, I get 2. This is dividing by 2, dividing by 2, 12 divided by 2, and again, that's not 2. Let's rethink that. If I really divided that right, I should get 192 divided by 48, that gives me 4. So really what I'm doing is dividing by 4, dividing by 4. 12 divided by 4 is 3. But remember, we show dividing by 4 as timesing by 1/4. That is the exact same thing. Dividing by 4 is the same as timesing by 1/4. That means this is geometric. I'm timesing, going to be one of these exponential graphs. If I'm going to write recursive, here's the equation for recursive. F of x equals f of x minus 1 times that 1/4 right there. Times, not division. Timesing 1/4, not division. And knowing that recursive is dots. All right, explicit. If I was to write explicit, I need to go backwards, which is the opposite of dividing by 4 or timesing by 1/4. the opposite of dividing by 4 is timesing by 4. So I take this 192 and I times that number by 4, and that gives me the number before 192, because that makes sense. Because if I take 768 and divide it by 4, it gives me 92. That makes sense. All right, so now for explicit, which is the continuous kind of answer, I have that green 768. I write that first. I have in parentheses that 1/4 number, because that's the number I'm timesing by 1/4. And I close that and I raise that to the x power. That is the explicit. And explicit, remember, is a line drawn through the points. Recursive is just dots. All right, moving on. This guy definitely is arithmetic. To find what I'm adding by, take those two numbers and just subtract them in their positive form. You'll see what number I'm adding. I'm adding 15. I'm not subtracting. I'm plussing 15. Since I'm plussing, that makes this arithmetic. Since I'm plussing, I could write the recursive equation. This is f of x minus 1 plus that blue 15 right there. That is recursive linear. That would be like dots in a straight line. If I do explicit, I do the opposite of adding 15. I take away 15 from this negative 59. So if I do negative 59 minus 15, that gives me the number before negative 59, negative 74. So for this equation, the equation is f of x equals that blue 15 right there in front of x minus that 74 number right there. That is the explicit form of this linear equation. That would be a straight line without any dots. All right, moving on. This guy, they want you to write the explicit equation using the 0 value. So here I go. If you don't know what's going on here, take those two numbers, divide them, and you'll see what you're timesing by right there. I'm timesing by 2, timesing by 2, timesing by 2. That's going to be my ratio number in parentheses. If I go backwards, I'm dividing by 2 or timesing by 1/2. That's the exact same thing. And what am I dividing by 2 or timesing by 1/2? This 12 right here. So 12 divided by 2 or 12 times 1/2 is 6. So for this equation, I would write f of x equals that green 6. That's my 0 number times that 2 raised to the x power. That's explicit geometric equation. That would be like a line drawn through. That's not straight. That's curvy. That's not recursive. Don't use dots. All right, moving on. This guy, which pattern is exponential? Exponential is the only pattern that times is times. You're looking for the multiply number, which has the same number being multiplied. That's what I'm looking for. If I look at this first one, it's going up by 2, and then going up by 3, and then going up by 3 again. So that's not neither linear nor that's nothing. If I look at this guy though, timesing by 4, timesing by that same 4, timesing by a same 4. That makes this exponential because I'm timesing. This one right here, I'm adding 4, and then going by 12. That's not even linear, not even the same pattern. This adding 1, adding 4, adding 4. That's not even linear either. None of those. The only one that's exponential that would be a curvy line is this one. And let me draw a better curvy line. There it is, exponential graph. Moving on. Number 11, these ones that we've been doing. The first thing, look for the exponential ones, knock those out. Knock those out. Those are the easiest ones. Those are the ones that have any percent symbol in them. Like this is a percent symbol. This is a percent symbol. Whenever you see anything with a percent symbol in it, that's automatically exponential. Look for that percent. Then, if it doesn't have a percent, if it's just a plain number, even if it's a fraction, that means I'm adding 1/4 each time. That would be linear. So I put number 1 in linear because that's going up by the same amount. The other two at the bottom are the only ones you need to do a little bit of math. So if I have 9, 13, 18, if those are going up by the same linear, this is going up by 4, but then it skips up and adds by 5. So that would not be linear because they're not going up by the same. That would be neither. If those were all going up by 4s, like maybe the next one would have been 17, then I would have put that in linear, but it didn't. So I leave it in the neither category. All right, last one has you actually do a little bit of work. Has me take $38 and divide it by 2 hours to get the rate or the slope or the number in front of x. 38 divided by 2 gives me $19 for every 1 hour. If I look at the other one and that divides and gives me that same 19 number, I know that one's linear. But if I look this, if I divide 54 by 3, that gives me $18 for every 1 hour. Since those are not the same, I put number 5 in the neither category because those are neither linear or exponential. All right, moving on. Number 12, for this guy, again, take these two numbers and divide them on your calculator. Divide the big one. So I'll divide 661.50. Type that on my calculator first. Divide it by 630. Type that one in second, and you'll get the number that I'm timesing. The only number times 630 to get a little bit bigger, 661, is timesing by 1.05. So that means if I'm going up the table, I'm doing the opposite. I'm dividing by 1.05. And what number am I dividing by 1.05? This 630. So if I take 630 and divide it by 1.05, it will give me that number above 630, which is 600. And that makes sense because 600 times 1.05 gives me 630. That makes sense. Going down the column times it. So now I have my equation. So my equation would be f of x equals that green 600 written first, in parentheses, that 1.05, and I'm going to raise that to the x power. That's going to be my exponential explicit. That would be a line drawn through the points. That's exponential. Always explicit is continuous. All right, here we go. 13. For this one, I needed to know that anytime I have an equation dealing with rent and a deposit, one number is always the deposit, the number without an X. The other number representing rent is always the number in front of X, because that number is constantly changing. How much you stay at a place depends on how much rent you pay. This one's saying which number is the correct interpretation of the y-intercept. This is the y-intercept. This would be the slope. That would be m. That's not the y-intercept. That green number is the y-intercept. That represents the deposit fee. The rent is $1,500. That's the rent. And of course, that last one's no good. The rent is $1,500, but I'm not asking for that number in front of X. I'm asking for the Y-intercept number. The deposit fee, nope, that's the rent. And then if I add these up, they don't add up to 3,000. So that choice is no good. All right, last one. Looking at graphs. First, again, your first category, linear or exponential, the way it's going to be on the test. Straight line or curved. So I look at choice A, it's not straight, so it's not linear. So that first one is exponential because it's curvy, it's curved, it's not linear. The next category, discrete or continuous. If it's discrete, it's dots. If it's continuous, it's a line drawn through the dots. Since this has a line drawn through the dots, this is continuous data. Only dots has discrete. All right, next one. Linear or exponential. Exponential is curvy. Linear is straight. So this one for B, definitely straight, linear. All right, next category. Discrete dots or continuous no dots. There's no dots here. So that for sure is continuous. And then my last one, here we go. Straight or curvy. Definitely curvy. Those dots are forming a curve. That's an exponential curve. All right, here we go. Dots or no dots. Those are dots right here. So that would be discrete data right there. All right, hopefully this helps. We'll be doing multiple versions. All right, good luck.